If you stand near a fire and walk away, you get colder, and everywhere in the universe, heat works this way except in one place, the sun. Somehow, the farther you get from its surface, the hotter it becomes, and this is one of science's biggest unsolved mysteries, known as the coronal heating problem. The sun's core burns at about 15 million degrees Celsius, but its visible surface, the photosphere, is much cooler at around 5,500 degrees, and following normal physics, everything above that should keep getting colder. Instead, the sun's outer atmosphere, the corona, rockets back up to 1 to 3 million degrees, which is up to 500 times hotter than the surface directly beneath it. Scientists first realized how hot the corona really was back in 1939 and 1943, when spectral lines in its light revealed temperatures they could barely believe, and it seemed to break one of physics' most basic rules, that heat flows from hot to cold and not the other way around. Despite decades of research, dozens of spacecraft missions, and hundreds of scientific papers, nobody has fully solved this puzzle, and it's known simply as the coronal heating problem. One leading idea is that magnetic waves, called alpha waves, ripple up from the sun's surface and dump their energy into the corona, much like a whip cracking harder at its tip. The other leading idea points to nanoflares, countless tiny magnetic explosions happening across the sun's surface every second, each too small to detect individually, but powerful enough together to superheat the corona. To finally solve this, NASA launched the Parker Solar Probe in 2018, built to fly directly through the sun's atmosphere, and in December 2024, it flew just 3.8 million miles from the sun's surface, closer than any human-made object ever has. In August 2026, India's Aditya L1 solar mission delivered a major clue, as researchers found that magnetic field reconnection, where tangled magnetic field lines snap and reconnect, could supply roughly 93% of the corona's energy, with surface waves contributing only a small remainder. This isn't just an academic puzzle. Since the corona is the source of the solar wind and solar storms, the same eruptions that can knock out satellites, disrupt power grids, and threaten astronauts, and understanding how it gets so hot could help us predict dangerous space weather before it hits Earth. Even with this progress, scientists say the exact balance between magnetic reconnection and wave heating, and whether the answer is the same everywhere on the sun, remains an open question. A star that gets hotter the farther you move from it, defying a rule of physics we rely on every day, and nearly 90 years later, we're finally closing in on the answer. So what other secrets do you think our own sun is still hiding? Let us know in the comments and subscribe for more mind-bending science from across the universe.